Okay, so if it takes so long to brute force a Sudoku puzzle, how are we ever going to be able to solve one um, at all? And how do people solve it by hand? So before we can write a computer program to do it, let's look at an approach for solving Sudoku puzzles. And the main concept here is we want to just reduce those possibilities and take the easy reductions that we can. So this is a Sudoku puzzle, and every red letter is the or red number is a number that we start with. And there's some really easy reductions because we know, according to the rules, if there's a 2 in this grid, then there aren't any other 2's. And so we can reduce that grid by erasing all the 2's. And not only can we reduce all the 2's from any cell in that grid, but we can also reduce all the 2's or eliminate the 2's from any cell in that row. And we can also reduce the puzzle by eliminating that 2 as a possibility for any of the cells in that column. And so the very first thing we're going to do, we're going to create a reduce method, or I've already created for you a reduce method that reduces on every row, on every column, or on the row and on the column and in the block for any cell that is solved. A cell is solved if it's got only one possibility left. And so once we've done that reduction, we're going to get a long ways, but we're not going to get a solved puzzle. Okay, so I've taken all the really easy reductions. And if I were solving this now by hand, I would look for other, a little bit more difficult techniques to try to figure out some answers. Like, for example, in this row, I know I must have a 9 because there are 9 cells and I've got to have the numbers 1 through 9 in some order in that row. And this is the only cell that has 5 as a possibility. So if I were doing this by hand, I would say, well, if that's the only place where the 5 can go, that must be where the 5 goes. And so I can just eliminate the other possibilities. So that one is solved, and now I can eliminate 5's in any other spot in that column and in that grid. And it looked like there weren't any others in that grid. I could also do some other reductions, like, for example, that are more complicated. There are lots of different strategies we can use for Sudoku. Like, for example, in this set of 3 cells, they're all in the same grid. And there are 3 possibilities, 1, 6, and 7, for those 3 cells. So I know that one of them has got to be a 1, another one has got to be a 6, and the third one has got to be a 7. Now, I don't know which ones are which, except that I know this one is not a 7. But I know that of these 3, one is a 6, one is a 7, and one is a 1. So, and they're all in the same grid, so there aren't going to be any other 1's, 6's, or 7's in that grid. So I can eliminate these possibilities. These are also all in the same row, so I can eliminate all the 1's, 6's, and 7's from any other cell in that row. And as you can see, some reductions lead to other reductions because now I know that this cell is a 3. Now, you could use these more complicated strategies, and you could write code to do them. The trouble is, with any particular Sudoku puzzle, it's really very hard to come up with all the possible strategies that would be necessary to solve the puzzle. So, what we do is we're just going to take the easy reductions, and then we're going to solve the puzzle according to this little algorithm. Okay, an algorithm is a process. It's a set of steps that you take to get a solution. And there are many, many, many different algorithms that could be used to solve this Sudoku puzzle. Here's the one we're going to use because it's rather short and simple and not too hard to program. We're going to start out. So main, let me actually, before we go into details, I'm going to say that I'm going to divide our program into several different classes. The top level class is going to be called solve. It's going to extend JFrame. It's just going to handle all the details of getting a window on the screen in Java. And it's going to have a variable main, which is going to have our board. Our board is going to have a 9x9 grid of squares, and it's going to call those squares my squares. Okay, the board is going to have its own squares. And each square is going to have a list of possibilities. That list of possibilities is going to be an array list of integers. So when we first populate our board, it's going to have a 9x9 grid of squares. Each square is either going to start out solved if in our input file that had a number in it, or it's going to start out with all 9 numbers, all 9 possibilities that might be in that square. And so then in our algorithm, we're going to take this main, okay, which is a board, the main that was created when we read our file, and we're going to reduce it. We're going to reduce the rows, the columns, and the squares by looking at any solved square and eliminating its possibility from any other square in that group, in that row, or in that column. So we're going to take the simple reductions that we can take. Then we're going to create a clone of that board. Okay, so main is a board. We're going to create a clone of main and call it temp. Then we're going to make a random guess on one of the unsolved squares in temp. Okay, so we're just going to pick a square at random, and we're going to look at all the possibilities for that square, and we're going to say, I think this is the right one. And so we're going to set that square in temp to being solved with that random guess. And so maybe this one we would guess a 5. And then we're going to reduce temp. Once we've guessed on a square, we've got a bunch of reductions that we can make. So if I've guessed 5 here, and that might be a wrong guess, but I can just go ahead and proceed as if it was a right guess and eliminate 5 as a possibility in any other row, column, or square. After we've reduced temp, if temp is invalid, temp is invalid if I've eliminated all of the possibilities from some square. If temp becomes invalid after we've reduced it, then go to step 2. What's step 2? Step 2 was create a clone of main. Remember, main was our original one we read from the file, so we know it's valid. And start over. So then create the clone, take another random guess, and reduce it. Now, if we've done a reduction and the board is still valid, meaning every square has at least one possibility, if temp is not solved, because after the reduction, hey, we might have a good solution. But if it's not solved, go to step 3, make another random guess. So hey, let's make another random guess. I'm going to guess this one is a 3. I don't know. It might be. So if I guess that is 3, then I have to reduce the 3's out of any other cell in that square, row, or column. So I've taken that reduction as far as it can go, and I'm going to say, is it invalid? No. Is it solved? No. All right, I'm going to make another random guess. How about I guess this one is a 9? So if I guess that one is 9, I'll eliminate 9 from that row that
May I have your
column.
attention, please? Varsity football players, Andy with First Jones will be here at 11:30 in the lower commons for ring sizing.
So I eliminate 9 from that row, that column, and that grid. And I ask myself, well, is it solved? No. Is it invalid? No. All right, we'll make another random guess. Maybe I'll guess this one is a 2. So if that's a 2, then I've got to eliminate 2 from any other cell in that grid, from any other cell in that row, and any other cell in that column. So now, I've guessed that 2, and I think I've done all my reductions, although I could have made a careless mistake. Now pick another random cell and guess. Oh, I'm going to guess this one is a 9. So if that's a 9, then I take all the other 9s out of all the other cells in that grid, in that row, and in that column. And then, is it solved? Nope. Is it invalid? Nope. So let's make another guess. Let's guess a 9 here. So I get rid of the 9s. Oh, look at this. I've just solved that square. So I can do some more reductions. And I'm going to write my reduce that if a square becomes solved, it keeps on reducing. So that's an 8. Let's guess a 2 right here. So I'm going to eliminate all the 2s in that grid, in that column. Oh, and I've solved this one, and in that row. So now, if this has just become solved, now I've got to eliminate all the 1s in that grid, in that row, and that column. Uh-oh, I got a problem. When I do this reduction, I've created an invalid square. It's empty. There's no possibilities. So at some point, one of my guesses was wrong. So according to our algorithm, temp is invalid, so I go back to step 2. Now, I messed up a little while ago. I didn't create a clone of main. Let's see if I can Control Z and get back to where I had a valid. So if I Control Z and go all the way back to where I was guessing, okay? And maybe I got back to where I was guessing, I don't know. In my program, it's very important to make a clone and to be really careful about that clone so that we get a full copy of the entire grid and can go back to where we started guessing. So how does this look in memory? So we've got this class solve, and when we first start out, we get an instance of solve. It's got 2 variables, main and temp. Main is read in from the file, and it's got, main is a board, which has a variable, my squares. That variable, my squares, is a 2-dimensional array of squares. Okay, a 9 by 9 array, and I've only drawn it as if it were 3 by 3, but just imagine that this array, this two-dimensional array, had 9 rows and 9 columns. Each square in that array of squares has a variable, possibilities. And in that variable of possibilities, well, that variable, possibilities, is an array. It's an array list of integers. And in that array list are all the possibilities for that square. And so some of the methods that you will need to implement are for square and board. For square, you're going to have to implement the random guess method. So if you make a random guess on a square, if that square is not already solved, it's going to pick one of the integers in its list of possibilities, and it's going to remove all the other integers. Okay? So for a square, if you make a random guess, it's going to eliminate all but one of the possibilities from the array list of possibilities. When you implement getSolution is going to return the one possibility in the array list of possibilities. Now, hopefully we only call this if it is solved, if there is only one possibility. When you implement remove is going to receive an item, an integer. And if that integer is in the array list of possibilities, it will remove it. For the square, you're going to implement isValid. A square is valid as long as there still exist possibilities in its array list of possibilities. If its size is greater than 0. You're going to implement isSolved. A square is solved if the size of the array list of possibilities is exactly 1. And since you're using an array list for possibilities, these methods of array list may be useful to you. Remove, you pass it an item and it'll remove an item. Size, you call it and it'll return the size of the array list. Add, if you're going to add an item, and so the idea for a random guess, you might say, I'm going to pick a valid integer in this array list of integers. I'm going to get that out, and then I'm going to create a brand new empty array list of integers and add that one thing I removed back in. And you may need the method get. You're going to get an item at some index. Random guess will probably be the most difficult method for you to implement. Inside of the board, you're going to implement isSolved. A board is solved if all of its squares are solved. So you just loop through all of the squares in that board and call the isSolved method on each of the squares. If any one of those squares returns false for isSolved, then the board will return false. You're going to implement random guess. It's going to choose one of its squares at random and tell that square to make a random guess. You're going to implement isValid. The isValid for a board is going to loop through all of the squares, calling the isValid method on the individual squares, and if any one of those squares returns false, that it's not valid, your board will return false. It's not valid. Okay? So that's the basic idea. In the next video, I'll show you some code.